Impulse and impulsive force. What is impulse? Impulse is defined as the change of momentum. So can you recall what is momentum? We learned it before. The momentum is the product of mass and velocity. Hence, the change of momentum we can calculate by using the final momentum minus the initial momentum. So it's a mv minus mu. The v is the final velocity and the u is the initial velocity. But remember that the momentum is a vector quantity. So the impulse is the vector quantity also. The directions of the velocity, the directions of the speed is important. So please remember that. Impulsive force is defined as the rate of change of momentum. Impulsive force is just a force that acts in a short period of time. So it's nothing special. It's just a term. When we say about the impulsive force, we refer the force that acts in a short period of time. Normally is like during a collision, in an impact. So impulsive force we can calculate by using the change of momentum over time, per times taken. So it's the mv, the change of momentum per the times taken. So this is the formula for the impulsive force. Okay, we try some questions from your textbook. So read the questions one. There's a car, 1005 kg, initial speed. After the car hit the wall, the car bounced back with the speed of 2.5 meters per second. And the collision's time, the times taken is 0.15 seconds. So calculate the impulse. Impulse is the change of momentum. Final momentum minus the initial momentum. Okay, in this question, we have to define the positive direction first. So normally move to the right is the positive. So we define this direction is positive. The momentum, the final momentum, the final speed is in opposite direction, is in negative way. So the final momentum is negative 2.6 minus the initial momentum, initial speed in the positive direction. So after that, we can calculate is negative 26,400. The unit for impulse is mass velocity, kg meter per second. So the second part, the impulsive force acting on the car. The impulsive force is the rate of change of momentum. Hence, we already find out the change of momentum and the times taken is 0.15 seconds. This is the impulsive force that will act on the car. You will notice that this force is a quite huge, quite a big force acting on the car because it happened in a short period of time. And the force acting in the negative directions, so the force will be acting on the car. This will cause the damage to the car. Okay, we continue to questions number 2. So there's a football player kick a ball with a mass of and the force is the contact time. So we have to find the impulse on the ball, and if the contact time increased to 0.013 seconds, what is the velocity of the ball? So we find out the impulse on the ball first. Impulse is the change of momentum. But in this question, the initial velocity and the final velocity is not given. The information given is the force and the contact time. But we know that the impulsive force will be equal to the change of momentum over time. The change of momentum actually is the impulse. Hence, the impulse will be equal to the force multiplied time, which is Ft. So we can find out the impulse. The force is 1005 Newton and the contact time. So we calculate out. This is 12 kg meter per second. Okay, this is the impulse that transfer to the ball. Now the contact time increased to 0.013 seconds. When the contact time increased, the impulse will be increased also. So in this case, the impulse that will be transferred to the ball is 19.5 kg meter per second. So we have to find out the velocity of the ball. When the player kicks the ball, the initial speed of the ball will be equal to 0 meter per second, the ball initial at rest, and the final velocity. So we can find out the final velocity. The impulse is mv minus mu. The initial speed will be equal to 0, so later on this will be equal to 0. So the mass of the ball, 450 grams. Remember to change to kg as our unit, and the final velocity we can find out. So this is the final velocity of the ball when the 19.5 kg meter per second impulse transferred to the ball.